subject matter, chemistry, alternative to practical, GCE. Our aim here at 300 plus academy is to ensure that you ace your next exam. Okay, moving on, we have another probable question for you. As you can see on your screen, you have a titration table, and of course the first question we've been asked here is for us to name a suitable indicator for this titration. This titration is actually between a strong acid and a strong base, sodium hydroxide and HCl. So question A1, A Roman figure 1, we were told to name a suitable indicator for titration and give reason. Of course, you're looking at between HCl and sodium hydroxide. This is a strong acid and a strong base, so it could be any indicator, but name a suitable indicator for it. Okay, let me use methyl orange. And still on the same question, A Roman figure 1, I was asked to give reason for my answer. The reason for my answer is very simple. The reason is because it's a strong acid versus a strong base. Okay, that ends question A1. Give the color of the indicator in the base and at the end of the reaction. Okay, A2 in the base. The color of this methyl orange in the base is going to be yellow, and at the end points, is going to be orange. At the end point is going to be orange. Okay, that ends that. And in A3, we were told what type of reaction is demonstrated by the experiment. Okay, A3. Of course, between an acid and a base, that is neutralization. That is neutralization reaction. Okay, that ends question A. That ends question A. We move to B. Write a balanced equation for the reaction. Okay, B. This is question B1. Equation for the reaction is HCl plus sodium hydroxide. Okay, for us to balance the sodium with chlorine, and of course hydrogen with the hydroxyl here, that gives us H2O. Okay, this is aqueous, this is aqueous, this is aqueous, and this is liquid. Of course, that ends that. We've been able to write the balance equation. Then that's B1. B2, we're told to look for the average volume of acid. Average volume of acid. Okay, looking at the table, our aim is to get the consistent titer. If you look at the first titration, 23.50, second titration, 23.10, a bit farther away, the third titration at 23.40. The first and the third titration looks concordant or consistent, so my average volume of acid here is going to be 23.50 plus 23.40, all divided by 2. I'm just going to use this 2, all divided by 2, and what I'm going to get is 23.45 cm cube. That ends B2. Okay, moving on. For C, I was told to calculate C1. I was told to calculate concentration of the acid in mole per dm cube. If you go back to the beginning of the question, okay, I was told to look for Ca in mole per dm cube. That's the question. Of course, my Va, if you go back to the beginning of the question, no, not the beginning of the question, the volume of acid used is 23.45 cm cube, and my Na here is actually 1. Then if you go back to the beginning of the question, was I given my Cb? Yes, I was given my Cb to be 0.065 mole, 0.065 mole per dm cube, and my VB talks about the volume of the pipette. The volume of my pipette here is 20.0 cm cube, and my NB is from this equation is 1. So with this, I can say CA over CB VB equals to NA over NB. So that what I have here is my CA is 23.45. My VA is sorry, I am looking for my CA. My VA is 23.45. My CB is 0.065 times my VB is 20 equals to 1 over 1. So that my CA, with this, my CA equals to 0.065 times 20 all divided by 23.45. So what I'm going to have for my CA, if I compute, is going to be 0.0554. 0.0554 mole per dm cube. That way I've been able to get my CA because I was given the condition of my base. So my base being a standard solution, I can then use that to standardize for my CA. So that answer C Roman figure 1. Concentration of the acid in gram per dm cube. Of course, I was told to get this in gram per dm cube. Concentration in gram, that's 2. C2. Concentration in gram per dm cube is going to mean concentration in gram per dm cube is going to mean concentration in mole per dm cube times molar mass. Okay, that's going to be 0.0554 times the molar mass, because my acid there is HCl, that is 36.5. This is 1, this is 35.5. If I take that together, that's 36.5. If I multiply this, my answer is 2.02 gram per dm cube. Of course, that ends C2. And then moving on, C3, mass of HCl in 20 cm cube of the solution. Mass of HCl in 20 cm cube of the solution. C3 says mass of HCl. Mass of HCl in 20 cm cube. In 20 cm cube of solution. Mass of HCl in 20 cm cube of the solution. Of course, since I already know the concentration of A in mole per dm cube to be 0.0554. So concentration normally is mole divided by the volume in dm cube. But in this case, my mole will be mass over molar mass, and my volume here is going to be volume in cm cube, because I'm dealing 20 cm cube now, divided by 1,000. So the 1,000 is going to move up, so that my concentration in mole per dm cube now equals mass over molar mass. The 1,000 goes up times volume in cm cube. So that what I have, what is the mass? The mass here is what I am looking for. Concentration in mole per dm cube is 0.0554. Mass is what I'm looking for, times 1,000 divided by the molar mass of HCl is 36.5. The volume is 20. So that my mass is 0.554 times 36.5 times 20 divided by 1,000. And that way, if I compute, I'm going to get 0.04 gram. And that just ends that very direct calculation and all of that. That ends C3. And with that, we've come to the end of this probable question. Do not forget, comment, like, share with your friends, subscribe, and turn on the notification bell, and do well to check us out on 300plusacademy.com, where you can link up with us on WhatsApp and message us anonymously on gray areas where you need clarity. From me to you, it's bye for now.